Alrighty, so let's do the Unit 7 review. I'm going to do this in chunks. So looking at question number 1 and finding the sine, cosine, and tangent for each angle, we're going to do this based off of the two different special right triangles, the 30, 60, 90, and the 45, 45, 90. So first thing is label the boxes for the triangles. That's going to help you with your sine, cosine, and tangent. So if we have two options. We can use x's or we could just use numbers. So one option is to say, well, if this is the 30, 60, 90, here's my hypotenuse. The hypotenuse is twice the length of the short side. So that means that this is x. And then this would be x square root of 3. Now, we can also just decide let x equal 1. Okay, so then I can actually say, well, then this is 1, 2, the square root of 3. Okay, over here with the 45, 45, 90 triangle, same idea, where the 45, 45, 90 have x and x because this is an isosceles right triangle. Those are the same sides. And then this would be x square root of 2. Well, if I let x equal 1, and then this is 1, this is 1, and this is the square root of 2. Okay, so I'm going to probably use the numerical values to assess the sine, cosine, and tangent of each angle, but you could also use the ones with the x's. All right, so for the sine of theta, if theta is 30 degrees. So with 30 degrees, we're using this as my reference angle. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So the sine of 30 is 1 over 2, which is 1/2. The cosine of 30 is adjacent over hypotenuse, which is the square root of 3 over 2. And the tangent of theta is opposite over adjacent, 1 over root 3. We can't have a square root in the denominator, so we're going to rationalize it. So we get the square root of 3 over 3. For the 45, we're going to go over to this triangle here. It doesn't matter which one we use. Let's use this top 45 degree angle. Opposite over hypotenuse for sine, so 1 over the square root of 2. Can't have square root of 2, so I'm going to rationalize it, and I get the square root of 2 over 2. For cosine, same thing, adjacent over hypotenuse. Well, that is 1 over the square root of 2. It's the same thing. So we're going to rationalize it and get the square root of 2 over 2. And then tangent is opposite over adjacent. So opposite is 1, adjacent is 1. 1 over 1 is just 1. Okay, then with the 60 degree, so now we're going back over into this triangle here, and we're going to do opposite over hypotenuse for sine, so that's the square root of 3 over 2. Cosine is adjacent over hypotenuse, so that's 1 over 2. And tangent is opposite over adjacent, so square root of 3 over 1, which is just the square root of 3.